Can't copy and paste my picture. All right. Chapter 3. Hang on. Remember I said you put the optimal solution into the objective function for the variables and you calculate what it calculates out to, and you just found the objective function value? Okay, once we get past this chapter 2, you're going to see output after output after output, and you need to realize these outputs are different ways, different software show it different ways, but they're all going to give you somewhere on there the objective function value. Do you see it on this output? Everybody see it? Give me a look, give me a handshake or something. You see it? Okay. You also, all that work you did when you found the binding constraints to either substitution method, addition method, subtraction method was to find the optimal solution. Every software will have it somewhere on there. Do you see the optimal solution here for this one? It's at the top where it names the variables involved and then gives their value. Those values are the optimal solution. Not every software has it at the top. So make sure you realize every software has the objective function value somewhere, and everyone I've seen calls it the objective function value, so that should be easy to find. Some softwares list the variables and put optimal solution, some put value, some put different words, but the optimal solution's on every one of those outputs somewhere, depending on how they name them. Next, you have the constraints in the order in which you enter them into the software. 1, 2, 3, however many constraints. And you're being told how much the slack and surplus is. It's calculated for you. And if you see 0 slack or surplus, you're probably going to have a question at the, could be even on your quiz, because we're covering chapter 3, right? Okay. You might have a question that says, here's a picture of an output. And one of the questions related to the output will say, out of the numbered constraints, which numbered ones are binding? And you know from the lectures that binding constraints have how much slack or surplus? 0. So you can look at this output and tell me constraints number what and what are binding? 1 and 2, exactly. Because they have 0 slack or surplus. We're going to get into dual prices. All the outputs will give you these dual prices. We're going to talk about them a little bit. Sometimes they're called dual values. Sometimes, I can't remember the other names. Every output has it on there. You just have to realize, what is it called on this output? Where do I find it? Because you're going to have to use it. Now, this area right here, called in this software is called objective coefficient ranges. Sometimes on another software is called range of optimality, and that's really the real name of it. I want you to write in your notes that optimality is all about the objective function, so you don't mix it up with anything else. The word optimality is all about the objective function, so you don't mix it up with constraints. Since you're right there in your notes, put next to feasibility, that's always referring to the right-hand side of the constraints, not the objective function. The word feasibility is always referring to the right-hand side of constraints. Optimality is always referring to the objective function. Optimality, objective function, feasibility, constraints. Got it? So you have this range of optimality. You have this range of feasibility. You have optimality 100% rule, which is talking about the objective function. Feasibility 100% rule, talking about the right-hand side of constraints. Right here is the range of optimality. Now I can look at that and know, even though I don't know what the objective function is and what the constraints are, I can pull the information off of here and I can literally write an objective function. I can write constraints. Because I look for current value, sometimes it's called current value, sometimes it's just called value. And with the variable x1, there's a number 10. So I know in the objective function it says 10x1. Probably says plus something with x2, 15. So I know the objective function says 10x1 plus 15x2, but I don't know if it's a max or a min. It's the only thing I don't know about it right now. I see that there's 2 constraints. Now this section is on every software somewhere, not necessarily at the bottom. And it talks about right-hand side ranges on this one, but other ones it might say range of feasibility, might be the heading. softwares have the same stuff, they just call it different things, they put it in different places. And once you get used to this, you could use any software at any company you work at, because you'll know what each of them mean, as long as you can find them. This is the range of feasibility. Let's go back to the range of optimality. Are you ready? Let's pretend this is a maximization problem. I'm going to start to lose people, so I want to make sure everybody's with me. It's not hard yet. It's about to get hard, though. You ready? Let's say this is our objective function, and this is a max problem. So let's say this represents the profit we could get from each one of these two items. Now, this is common occurrence. We did all this research. We have these two new products. We went ahead, accounting majors went ahead and spent all this time calculating what our cost will be to manufacture it. We ran test manufacturing even to get the time involved, the hourly cost for every one of those items. We figured out what we're going to sell them for to be competitive in the market. We figured out our gross, subtracted some overhead, and we got our net contribution to profit, $10 and $15. All of a sudden, we're just started production, and we're making X1, 15 of them, X2, 17 and a half of them. This is our first product run, our first week of production, and someone just comes into your office and says, hey, I told you that the supplier was going to, well, we just got our first invoice, now that we're starting to make them, and the cost is not what we expected. They said there was a mix-up, and they charged us a little less. So the profit on this first product is not going to be $10 each, they're going to be $12 each. Is that going to change this optimal solution? Should we be stopping production right now, even though it's Monday, and get things reorganized? Does it change things? What do you think the answer is?
Yes.
Does it?
No.
Oh. Well, what'd you base your answer on? Just the fact that a change is taking place? This is where this output comes in handy, because in real business, sometimes you've got to make decisions fast. And I grab an output like this, and I look at what that range is, and I look at what the upper limit is. Some of them will say allowable increase. And I say, okay, if that profit's going from 10 to 12, as long as it's within its range of optimality, that optimal solution of 15, 17 and a half, still valid. Still valid. Keep going. Don't stop production. It will change how much our maximum objective function value equals. But that 15 to 17 and a half are still our optimal solution. We're not making $10 now. You ready? The objective function is where you take the optimal solution, plug it into the objective function so you can multiply it times the numbers with the variables. Right now, that $412.50 is $10 in the objective function times X1, which optimal is 15. 10 times 15 is 150, right? $15 is in the objective function. The optimal solution is 17 and a half, whatever that equals. Add them together, it's 200 and whatever, you get $412.50. But you just found out that you're going to make more profit on that first item. It's not $10 each, $12 each. You just told me that you are writing, since the change is within the upper limit, the optimal solution is still valid. The question is going to say, if the optimal solution is still valid, what's the new objective function value? You can choose any way you want to calculate it. You can say, okay, this is 10 times 15, so now it's 12 times 15, plus 15 times 17 and a half. You could recalculate it. Or, those who love numbers, the shortcut would be, this is going up $2, I'll multiply $2 times the 15, and add that to the objective function value, and that'll give me the same answer. That's kind of a shortcut. Everybody with me? Everybody's okay? All right. We just found out that we're going to make less profit for whatever reason on the second item. And instead of making $15 each, we're going to be making $6 less on each one of X2s. Is our optimal solution still valid? I hear a yes, I heard a no over here. Yes and a no? Anybody want to tell me why their answers, do they feel strong enough to tell me why?
Because it's still within the limit.
Because even though this was 15, going down to 9, I said? 6?
No.
Going down $6,
Yeah.
which will take it to 9?
Yeah.
Okay, going down $6, it takes it to 9. This is called the lower limit. be careful. Sometimes this is called allowable decrease. If it's called allowable decrease, and I said it's going down $6, oh, it's still within, isn't it? All right. So hopefully I had an example where it wouldn't. But it can go all the way to $6.67. I'm taking it down $6 to $9. It's within the lower limit. Optimal solution is still valid, but you have to calculate the new objective function value, which would be 10 times 15, and instead of 15, 9 times 17.5, add them together. The objective function value will be a little lower. Matter of fact, it will be, what did I say, $6? Is that what I said here? 6 times 17.5 subtracted, same answer. And that's your new objective function value. That's where this is all heading on your next quiz. You're going to see an output on it, I can guarantee you, and you're going to be asked these kinds of questions. Hey, someone just came into your office, you just found out that the profit, that this is a maximization profit problem, and X2's profit is no longer going to be 15, it's going to be $6 less. Is the optimal solution still valid? And if so, what is the new objective function value? I want to make sure we're all on the same page. X1's profit went from $10 to $25. Is the optimal solution still valid? No. Exactly. I wanted to give you an example where this is going above the upper limit, and your answer is going to be, because that change is outside the limit, the optimal solution is no longer valid. Now, you got to make sure you're correct, because if you don't go forward and calculate the new objective function value, which you don't have to, because the optimal solution is no longer valid, but if you're wrong, look how many points you're losing by showing no work on that new objective function value. I'm bringing this up because if you don't feel 100% confident on a problem where you're stating this is no longer valid, needs to be redone, you're skipping a bunch of work, which could be correct. But if you don't feel 100% confident that that answer is correct, leave the answer, but still do the work and calculate the new objective function value just in case you're not correct, and you won't lose a bunch of points then. You're barely losing points because you said yes instead of no, or no instead of yes. Okay? So maybe go ahead and calculate the new objective function value, no matter how you determine whether it's valid or not.
Is calculating that not held against us?
No, if you do a calculation it wasn't necessary, it's not going to be held against you. No. You're already hurting yourself by using time. That's the penalty.
Sure.
All right. You now know about the range of optimality, and I want to make sure you realize what it is we're doing. Because, hang on, what is going on here? Hang on. What we just did is after you graph it, here's that objective function line that we kept moving out and out and out, and we found the optimal solution. When those objective function numbers change a little bit, you're actually changing the slope of that objective function line. And that line can change that much over here, it can change this much over here, this is each of the numbers that are changing, and it will teeter-totter with the same optimal solution. But once it goes out a certain range, and the PowerPoint shows you how to calculate that range, but I'm giving you the range on the output. Once it goes outside of those ranges, the optimal solution is no longer valid. One of the other extreme points is going to be possibly the optimal solution. So that's why you got to redo the whole problem. In real life, redoing a problem takes a lot of time because you have multiple constraints, multiple variables, not just two constraints or two variables. All right, next. We're going to get back where I was. Right. You read all this. It's pretty accurate. All right. This is called range of feasibility. Now I can look at that and go, oh, constraint 1 is something, either less than, equal to, or greater than, equal to 100. The second constraint, something, less than, equal to, or greater than, equal to 80. And these happen to represent raw materials maybe. We knew we were going to get 100 pounds of one raw material and 80 pounds of another raw material. We calculate everything based on those raw materials showing up. We're at our first week of production, whatever week of production. And all of a sudden, you're production this time. You're not even finance, you're production. And you just got told that only 90 pounds of the first raw material showed up, not 100. Should we stop everything. This is going to change what's happening here. When you're evaluating the right-hand side of a constraint, you're determining whether those dual prices that are associated with that constraint are still valid or not. I'm going to explain what, I know you haven't heard of dual prices yet, sometimes called dual values on other software. Those dual prices and dual values are telling you, for the corresponding constraint, how much it will affect the objective function value at the top. For every unit, the corresponding right-hand side, I don't see anybody writing this down, but I want to make sure you get this. It's telling you the effect it will have for every 1 unit, the right-hand side goes up. Hear that? Goes up. Everybody hear it?
That's what dual price is?
That's what the dual price is. So for example, if this 100 goes up 1 unit to 101, it will have a, that's a positive 3.125, right? It will have a positive effect of $3.12.5 to that objective function value. Then you got to determine whether does that mean add or subtract it. Don't make the assumption you're adding it. Then you go and look. Oh, it's a maximization problem. You got to say, if that's a maximization problem, that 412.50, maybe that represents profit or revenue. It's a max. So as a manager, what would a positive effect be for that number to go up or down? Exactly. So if this goes up to 101, has a positive effect of $3.12.5, you're adding $3.12.5 to the objective function value because that would be the positive effect. Stay in the same mind frame. This goes from 100 to 101, went up 1 unit. But that's a negative 3.125. For every 1 unit it goes up, it says, it's trying to tell you it's going to have a negative effect. And then you go and look and see if it's a max or min to determine whether you add or subtract. Since this is a max, a negative effect would be subtracting 312.5. Hang on, I'm going to go one more while we're all in the same mindset. This is going down 1 unit instead of up. It's a positive, we're going back to positive 3.125. If this goes up 1 unit, it's going to have a positive effect of $3.12.5, but this is going down 1 unit. Anytime the right-hand side of the constraint goes down instead of up, the opposite effect of whatever the dual price or dual value says it's going to have, it's going to have the opposite effect. So if it's going up and it says it's going to have a positive effect, because it's going down, it's going to have the opposite, which is a negative effect. Then you determine whether you add or subtract by determining what does negative effect mean. Well, if this is a max, you'd be subtracting. If this is a min, you'd be adding, because cost going up is a negative effect. Now, I'm ready.
So that objective function value, that's dollars, right?
I'm using dollars in this example. It could be anything though. That's telling you how much it goes up and down, whatever that's expressed in.
Okay.
Dollars. I don't know. Hours. I don't know. Something. Usually it's dollars. And I know it's a lot of them. I like the example I'm going to give you after is you're minimizing the number of employees you schedule. So in that case, it's minimizing employees. And this will tell you how many employees will be affected with a change of this. So there you go. It could be anything. But that's in the same units as the objective function value, the dual price ratio. All right, I want to make sure you get this. You ready? The right-hand side of the second constraint is currently what number? 80. And it's going down to 70. Is the dual price corresponding with that constraint still valid, yes or no?
Yes.
Is it? 80 is going to 70. The lower limit is a 50. 70 is within that lower limit, so he's right, that dual price is still valid. Now, is that dual price telling us that this change is going to have a positive effect or a negative effect on the objective function value? Negative effect because the dual price is positive. If 80 were going up, it would have a positive effect, but I told you it's going down, and that's why he's saying he knows it's negative, because it's going to have the opposite effect. But it's going down 10 units, right? You're going to multiply, which one is it, $1.25? You're going to multiply the 1.25 by the number of units that are being changed on the right-hand side, which is 10. So that takes it to 1250. Okay, negative effect, 1250, minimization problem, add or subtract. That's right. Everybody hear him? Right.
You add it?
You add it, because if it's a minimization problem, that's probably a cost up there. And a negative effect, would, if it were increasing, that's bad. You got to get in the mindset of a manager. Well, how would you interpret that as a negative effect? Increasing or decreasing? What would be bad? If that's a max problem, then maybe it's profit or revenue. A negative effect would be decreasing. That's how you got to look at it. I already had people in the other section starting to write their charts so they know whether to add or subtract. And they're showing me it, and there's a whole, everyone's skipping part of the process. You can't make assumptions that you add or subtract based on whether that's a positive or negative dual price. You got to make the assumption whether you add or subtract whether the objective functions minimize or max. That's what you got to base your decision on, not on whether it's a positive or negative dual price. Everybody get that? Base it on. So do one if the objective function's a max. Is how I would do it, and do another one if the objective function's a min. And then when you go for your little cheat sheet, so you don't have to sit there and stare at it forever to figure out whether you add or subtract, make sure you look at whether it's a max or a min problem and grab that one, and you'll just follow your steps then and know whether to add or subtract. Okay? You ready? I want to do one more, then we're jumping 100% rules. What was there? Our amount of the raw material did not have 100 pounds showed up, only 50 pounds showed up. Is the dual price value, whatever you want to call it, still valid? No. Because only half of our raw material showing up ends up taking us below the lower limit, which is outside the range, and you're going to write this change is outside the limit, therefore the dual price is no longer valid. And you can stop there, but it's going to say if the dual price is still valid, calculate the new objective function value. If you feel 100% confident that this dual price is no longer valid, then you can just stop right there. But if you don't feel 100% confident, quickly just calculate the new objective function value, just in case. Which you would say 50 times 3.125, positive effect if it goes up, so it's going to be negative effect. 50 times 3.125, negative effect, it's a maximization, I'm subtracting. That's how you do it. You just quickly multiply and subtract just in case you accidentally, it's not outside the limit, you misinterpret. All right, before I go on, I'm telling you, all of you are looking at me like you got this, no problem, but that scares me. Come on, I gotta find a random output. I'm putting you to the test. Here we go. Here we go. Just a random output. Looks like we've got, I'll ask you what we have. How about if I turn it on? One time I don't turn it on, the next time you need it. Let's turn on the autofocus, let's turn on the light. This whole thing is not turning on at all. Anybody have their book? Page 130. If you've got your book and someone's sitting next to you, share your book. All this thing's trying to turn on. Page 130. How many constraints? How many variables are involved with that output on page 130? Anybody?
3.
I don't see variables. Not constraints. Variables. 2 variables. Now, how many constraints?
3 constraints.
3 constraints. There you go. What is the optimal solution for the variable m? Oh, here we go. Here we go.
240.
Yes. What do you say?
240.
Exactly. Look at where he got that from. This output looks very similar to the output you've seen already, but it's different. I can see a change already. Look at the dual prices. What are they called here? Dual value. Look at the upper limit for the objective function value that had, I don't know, with W. With W. First of all, what's the current number in the objective function with W? You see it? 1. It is 1, but look at how it's not in the center like the other output is. It's off to the left. See where it says W, objective coefficient. It doesn't even say current value. It says objective coefficient 1. This doesn't have the upper limit. This has the allowable increase. And if you say, oh, I need the upper limit, just add 0.25 to 1. The upper limit is 1.25. Instead of the lower limit, this is the allowable decrease. You would have to subtract it from 1 if you want to know that number. See how these outputs are, and this one's about as close as you can get to the one in the PowerPoint. A lot of these outputs look very different, but they have exactly the same information, just different ways of presenting it, all of them. Yes?
So like for the allowable decrease, that means it could be decreased by that much?
That much.
Not to that much?
Including that, up to that much. So where are we at? 1 minus 0.10714 is 0.89 blah blah blah.
But you couldn't decrease it to 0.107?
No. That's telling you how much.
Oh, okay.
Yeah, the other output is telling you what you can decrease it to,
Okay.
but this one's telling you how much. I know. Every output is giving you the same information different ways. That's why you got to get comfortable with this, no matter what output I throw at you, or in the real life, what output that company you're going to work for happens to be using, you can interpret the output. That's what I need to get you at. That's what I'm trying to get across to all of you. And I need you to be able to, you're going to be in a meeting, and this output's going to come up for some big decision that's happening. You need to be able to understand what you're looking at, no matter which software somebody's showing you the output from. Okay. All right, you ready? Hang on, let me make sure. Our constraint 1 happens to represent the number of hours for that month or year, or I don't know, for the month in Department A. Constraint 1. So look at the current value, the right-hand side of constraint 1. You see the hours, right? But somebody just got injured. And so we have less employees. We have nobody to take that spot, and that's a skilled trade type person. Nobody can do that job. And so everything that has to be done in there is going to take a lot longer, and we don't have the hours. We have to lower it. We have to lower the hours for that department by 40 hours. So we're going from 4480 to 4440, because all those hours are available. My question is the dual value or dual price still valid for that constraint?
Yeah.
I hear yes. What they looked at is they said it's currently 4480. If you reduce it by 40, it could be reduced by 160 hours. And that dual price is still valid. Then it will say, if the dual price is still valid, what's the new objective function value? It will say that no matter if the dual price is valid or not. So just, I'm asking that even if you aren't supposed to do it. So, no tricks here. And you're saying yes. So you're going to take, how much did I say it's going to go down? 40 times what?
0.125.
That's right, 0.125. You ready? Positive effect or a negative effect is going to take place here. I can't hear it. That's right. Everybody hear that? The dual price is positive. And if I said this was going up, it would have a positive effect, but I said it's going down 40 hours, so it has to have the opposite, which is a negative effect. You're going to multiply the 40 by 0.125, so 12.5 cents times 40. This is a max problem. Are we adding or subtracting that, whatever that calculates out to? Subtracting. Negative effect on a max would be subtracting. You got it. Okay. I know I've only lost maybe a couple of you, and I think you're coming around. I think we did enough examples, but I got to lose the rest of it. You ready? All right. Now, optimality, which has to do with the objective function numbers, and feasibility, which has to do with the right-hand side and constraints. Anytime a problem reads that you have more than one change taking place in a category, more than one change taking place with the objective function numbers. For example, hey, our profit on the first one's going from 10 to 12, and the second one's going from 15 to 17. Both are changing because the supplier supplies the materials for both of those products. Because we got a lower price, both are increasing in the profit contribution. With me? Because there's more than one changing in the optimality objective function. That's called simultaneous changes. Any number above 1, it could be 2 changes, 3 changes, 4 changes. We could have 5 variables here, and if any more than one of them are changing at the same time, you must calculate this 100% rule and show that work. You must do this. Now, ready? More than one change taking place. Step one, evaluate if each change is within its limits. And you got to tell me in your answer if each change is within its limits. Let's start with the first one. 10 is going from 10 to 12. Is it within its limit, yes or no?
Yes.
You're writing that 10 going to 12 is within its upper limit. We're still good. 15 is going to 17. Is it within its upper limit? You're writing down the change of 15 is going to 17 within its upper limit. We're still good. And right now, your instinct on this quiz is going to be the optimal solutions are still valid, and you'll calculate the new objective function value. You think you're done. But you forgot. Anytime there's more than one change taking place, you must calculate the 100% rule. You do not know if that optimal solution is still valid yet. Even if every single change is within its limits, you still don't know. You have to do this calculation. Okay. This is the hardest part for a lot of people. You ready? How much change did I say the 10 X1's profit contribution is going to go to? How many unit change did I announce?
40?
No, I said it's going from 10. That's the other problem. It's going from 10 to what? 12, which is how much change? 2 units. So this one's going from 10 to 12, which is 2 units. Now, I want you to hear these words. I don't know if you want to write down or how you're going to remember this. You divide it by the amount of change that could have taken place for that number in the same direction of the change that is taking place. Now, did you hear that? Because no matter how I present this, someone's going to give me the amount of the whole range. And that's not what I'm asking for. That's not what you use. You divide the amount of change by the amount it could have changed in the same direction. It's going from 10 to 12, right? Which is a 2-unit change. But it could have went in the same direction from 10 to what? Well, that's the amount. But to what? 2.5. Now, if this were the other software, it would say allowable increase. You're given that number that I'm describing to you, the amount it could have increased. But with this output, you've got to calculate the amount. It could have went from 10 to 22.5, subtract the 2. The amount it could have increased in the same direction it's going is 12.5. Mike, you took 2 divided by 12.5. What did you get? Oh, you were way ahead of me. No. Point something. Let me see. It's not even point. It's 0.2 something. 0.1817. Help me. Come on. Calculate. Am I getting Siri out of my pocket? Don't make me bring her out. She's not even dressed.
0.16.
Okay. 0.1666 probably, I'm guessing. Does that sound right? There's nobody in this room. We're recording, but nobody's here. All right? Here we go. The other one I said is going from 15 to 17. Is that correct? Yeah, when you get old, you'll question me what you think. 15 to 17, which is how many unit change? 2. This is going from 15 to 17, which is 2-unit change. It could have gone how many units?
5.
No, come on, it's going 5. It could go from 15 to 20, which is 5 units. Do not put this full range. Do not put, what is that, like 13.333. It's just the amount it could have went in the direction the change is taking place. 2 divided by 5 is 0.4 what? Oh, thank you. 0.4, which is 40%. 0.1666 is 17%. I add together, I get 0.56666. You must show me now you are comparing this to 100%. You can put it's less than or equal to 1.0. You can put 57% is less than or equal to 100%. However you're going to write it, you need to write something that shows me that you knew the next step was to compare all of these changes added together to 100%. And if, actually, Mike, 1 second. If this adds up to 100% or less, and if there's 3 changes, you're adding 3 of them, because there could be 3 variables. If the simultaneous changes add up to 100% or more, or just say, I'm sorry, more than 100%, that optimal solution is no longer valid, and this whole problem has to be redone. But if these add up to less than like ours, now you've proven the optimal solution is still valid, the 15 and the 17 and a half. and you can calculate the new objective function value. And you're going to take that 17 instead of 15 times the 17.5, this 12 instead of the 10 times the 15, and you will get the number, the new objective function value, which will be bigger. Or you can just take 2 times 15, which is 30, add that. 2 times 17.5, which is 35, add that. There's your new objective function value. I keep showing you 2 different ways to get the new objective function value, because for me, one takes a little longer and one's a little shorter. But do it the long way if you don't feel comfortable with the numbers.
So I just looked in the book and one of the allowable increases is infinite. How would you do that?
Yeah, if it's infinite, you ready? Any number. I'm going to use the number. Let's say this was 2 over infinity. Think about it. I want you to take a calculator and take 2 divided by, just put 999 for as many spots as you can put in and hit equal. And tell me what you're going to get. Anybody know what you're going to get?
0.
It's going to be 0.000000. There might be a 1. It may be on your calculator. It may be, say, let's say 0.1 times negative something, meaning it's way out there. Any single number that you divide by infinity is the same pretty much as 0%. It's so small, so nothing. You might as well call it 0. You're adding a 0 in your calculation. Don't get me wrong. If you come out at 99.99, then that's a big deal. But I'm not going to try to trick you. I solve the problem before I give you the quiz, so I'm not going to have this add up to 99.9. You're going, oh, I'm divided by infinity. Is that going to affect it? No. Just use 0. All right, you ready? We're doing feasibility rule, 100% rule. Feasibility now. This is the right-hand side. The logic is the exact same. But what we're testing now is rather the dual. I'm sorry, Mike, I forgot to answer your question.
Oh, I was just going to say 6 is repeating.
It's repeating?
It's not repeating.
Oh, it's just really 1.6? Thank you. My mistake.
It doesn't change.
Or 0.16. It doesn't, but it changes that. That's 56 then. And then it changes that. There we go. Thank you. All right, you ready? Range of feasibility 100% rule. Same concept. Our suppliers dropped off instead of 100 pounds, 90 pounds. And the other supplier, instead of 80 pounds, 70 pounds. No, don't write that down. Instead of 100 pounds, 90 pounds, instead of 80 pounds, 90 pounds. I'm trying to trick you, go in both directions so you can see an example. All right? Hang in there. Step 1. There's more than one change taking place. You must evaluate if each change is within its limits. You've got to show me that you checked if they're in their limit. 100's going to 90. Is it within its limit?
Yeah.
Yes, it could go all the way to 53 because this is a lower limit. The 80's going to 90. You're both going to be 90. Is it within its limit?
Yeah.
Yes. You're writing down 100 to 90 is within its lower limit. 80 to 90 is within its upper limit. You got that first step down. Step 2, 100% rule. Here we go. 100's going to 90. That's 10 units divided by what?
74.
You hear what he's trying to do? It's 60, not 40. 100 minus 53.33 is the amount it could go down. Because this is going down, we only want to know how much it could go down, which is 60, or what is it, 40? 46 point something. 46.7? 46.66666? Something like that. Am I close? Am I close? Thank you. All right. Give me a percent of that. 0.2 what? 21, 22? Did I do this myself? Then 0.21? What's the next digit?
4.
Okay, I'll take it. The next one's going from 80 to 90. So 80 to 90, which is a 10-unit change. Look at the direction it's going in. You're going to divide by the total number of units it could change, which is how many units? 70, because it could go all the way from 80 to 150, which is 70 units. You're getting here 0.1, help me out, 10 divided by 7 is 0.1 what? 1.4? What's the next digit?
2.
I'll take it, 1.4. I'm checking your rounding. 2, 3, we added up, we got 0.35. Now you've got to show me that you're comparing it to 100%, which is 35% is less than or equal to 100%. Therefore, what did we just, therefore what? What did we just find? Therefore what?
Objective function?
No, now, that has nothing to do with the objective function. This is feasibility.
The limits are the same?
The what's the same?
The limits are the same?
And not the limits.
Dual prices.
The dual prices. We just discovered by finding that these changes on the right-hand side of these constraints are within 100%, we now know those dual prices are still valid.
So that's only for the feasibility one?
Yeah, feasibility, you have nothing to do with the objective function.
Okay, and the optimality is the.
Optimality, yes. But here, this is all about those dual prices. The objective function is all about the optimal solution. So now that we know, we checked the limits, we checked the 100% rule, we know the dual prices are valid, we got to calculate our objective function value, our new one. You ready? 412, here we go, 412 and 50 cents. I'm going to do the first one. It went from 100 to 90, which is a 10-unit decrease. If it were increasing, it would have what kind of effect? Positive or negative? If it were increasing, positive effect, but it's decreasing, so it's going to have the opposite, which is a negative effect. A negative effect of how many units? 10 units times 3,125 is $31.25, right? Is that 10 units? Add or subtract. Is this a max or a min? I forgot.
It's a max.
Max. We add or subtracting this
Subtracting.
because negative effect would be subtracting. Now we're looking at the next one. 80 is going to 90, going up 10 units. The dual price is, 1.25, we'll multiply times 10, we get 12.25, is that right? No, 12.50, sorry. 12.50, that's a 5. Am I adding or subtracting this? So let's evaluate this. 80 is going to 90, it's a positive 1.25, which means positive effect. This is a max problem, are we adding or subtracting? 412.50 minus the 31.25 plus the 12.50 is our new objective function value. One's being subtracted, one's being added. Everybody get it? We got it? This is usually where I start to lose a few people on this, especially when it comes to figuring out whether to add or subtract based on whether it's a min or a max.
Yeah, can you go over the adding and subtracting?
You ready? I want to go over it again, but make sure you put your notes this time it's a minimization problem. And can I change one more thing? Also put in your notes, just for this example, we're changing that 1.25 dual price to a negative 1.25. It says negative. So, clear the board. How are we doing on time? We okay? We got time for this? Where's the sign-in sheet? Everybody signed in? Okay. You're doing anything on your way out? Here we go. Same thing, 100's going down to 90, 100's going down to 90. We already did the 100% rule. We know we're within it. The other one's going from 80 to 90 also, but it's going up. The other one's going down. The dual price for the first one is $3.12.5. The second one is negative 1.25, right? That's the change we made. Everything else is the same, right? Except, it's a min, right? Almost forgot. Min. Here we go. The first one is going down 10 units. 10 times, what's the current? 412.50. 10 times $3.12.5 is get that out. 1.25, $31.25. It's a positive 3.12, but the right-hand side of the constraint is going down, so it has to be a negative effect. It's a minimization problem. Am I adding or subtracting here? Adding. Negative effect on a minimize would be adding, increasing that minimum cost. It would be bad for it to increase. That's why a negative effect. Everybody ready? Next one's going from 80 to 90. It's increasing. If it's increasing, it has a negative effect because it has a negative dual price. 10 times $1.25 is $12.50. It's increasing. Negative effect. Do I add or subtract on this minimization problem? Add. You're adding both. Negative effect because it's going down, negative effect because it's going up. Both negative effects are added because it's a minimization problem.
So a negative effect on a minimization problem is adding.
Exactly.
A positive
Effect on a minimization problem would be subtracting. And then the opposite is true for max problem. And I would separate my little, what I do if I'm making something with minimize and a max, because that's where people get mixed up on the decision. When you're in a hurry, oh, it's a positive 3.125 and this is going up, I'm adding. When that's not necessarily true. It all depends if it's a min or a max.
And a minimum effect on a max is subtract.
And what effect on a max?
Minimum or negative effect on.
Negative effect on a max would be subtraction, yes. All right, let's see. You're working for this bike manufacturing company. You're looking at two different frames being built, a deluxe and a professional. The anticipated profit is $10 for every deluxe you're going to manufacture, $15 for every professional. The number of pounds of alloys that got dropped off at the dock for this week's schedule of production is 100 pounds of aluminum, 80 pounds of steel. If you're building a deluxe bike, it's going to use 2 pounds of aluminum, 3 pounds of steel for every one of them you're building. If you're building a professional frame, 4 pounds of aluminum, 2 pounds of steel for every one of those. How many variables are involved? 2 variables, because you're trying to decide how many of each frame you should build, and there's 2 frames. And the objective function is $10 for every one of these frames, and a $15 for every one of those, and because these numbers are profit contributions, this is the max. Our limitations is the amount of steel and aluminum got dropped off. So the constraints are written as to how much aluminum each frame uses. 2 and 4, go back here real quick, make sure you see this. Each frame uses 2 and 4 aluminum. Each frame uses 3 and 2 pounds of steel. So you write that as a constraint for the steel. 3 pounds, 2 pounds, less than equal to 80. You should look familiar because we've been using these same constraints this whole lecture so far. And then you graph them, or no, we fed them into the software. By the way, the software is now on Blackboard. Right there at the bottom under course information, it's in a zip file. Right, so you download the zip file, extract it, and you have the software. And then go. So let's say I opened up the software. Don't forget, the first time you open it, you're going to get an error message, possibly close it, right-click on that executable file, open as administrator. It will work. You say yes, it will work. Every time from that point on, you can open it any way you want it to work. It's that first time, open as administrator. Select number 1 when you're programming. Does somebody have that? Make sure I have this in front of you. Objective function and constraints, because I need these numbers. 10, 15, right? Here we go. File, new. How many decision variables are there? 2. How many constraints? Max or min? Go. I'm going to change these to the variables we're using, which happen to be the x1 and x2, though. We are using, aren't we? So the numbers in the objective function is a 10 and a 15. The first constraint has, I got to look, 2, 4, and 100. So 2, 4, less than 100. Notice I didn't have to type equals. It assumes less than equal. You just type less than. The next constraint has 3 to 80. 3, 2, less than 80. Look good? Any errors? Solution. Solve. The output look familiar? The one we've been using this whole lecture. And you're going to see something like this on your quiz. And you're going to be asked, how many constraints are there on this problem? How many decision variables are involved?
2.
If this is a maximization problem and the profit contribution for the X1 is decreased from 10 to $8, is the optimal solution still valid? And if so, how will you calculate the new objective function value? First of all, is the optimal solution still valid?
Yes.
Because it went from 10 to 8, and you notice it's within what? The lower limit. The change is within the lower limit, which happens to be $7.50. You getting it? Now, the quick way is, it went down 250. 250 times 15 is 37.50.
So it went down to 8, not 750.
Oh, it went down $2. Okay, $2 times 15. Thank you. $2 times 15 is $30. I'll subtract $30 from $412.50. There's my new objective function value. Or you could just take, what is this now? 8. 8 times 15. 15 times 17.50, and you'll also get the same number, same calculation. This is where it's all going. You guys now understand how to read this, correct? The old on Monday, you're going to learn a little bit more how to read this. We did talk about reduced cost, and there's different ways to interpret the dual prices. We just got the basis at this point. All right, but I think that's enough for today. It's a lot.